Okay, so in the first video clip, we had this discussion, and we went all the way down here, but I didn't get a chance to talk about well-defined set because I write too big. So the question is the set above, right, our S, our capital S of our class, right? I don't know, X1 could be, again, one student, X2, another student, dot, 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 all the way to the 20th student. Is this a set, is S well defined? Okay, so what does well defined mean? So I'll just move up here. So a set is well defined, meaning that its contents can be clearly determined. Okay, and we did write that, I did write that up here, right? Clearly determined, I think I put it in blue. So clearly determined. So using this criterion, if we say, okay, the collection of students in this class. So if I asked, for example, I don't know, I'm just, okay, thinking of a name, let's see, Amani. If I ask Amani to write on a piece of paper the name of every single student in our class, right? 1, 2, 3, all the way to 20, no specific order. And I ask, I don't know, Jasmine, right, on her piece of paper to write down, again, all the students in the class. If I compare the two pieces of paper, I'm still going to have the same number of students here and here. They might be in different order, but I mean, it's pretty clear. We know that there's 20 students, distinct students, in this class. So what is a set? So our sets that we're going to be talking about are going to be well defined, but what's a set that's not well defined? Well, if I ask you, what are the, oh, I don't know, let's see, let's pick a different color here. If I ask you, I don't know, B, set B, I want you to list, I ask, let's see, Zachary. If I ask Zachary, list all the students, right, in, our Math 107 class, right, my section specifically, list all the students in our class who are, okay, bad at math. Well, I mean, this set is not well defined because, I mean, our, how are we interpreting, depends how we interpret the word bad. I mean, Zach might say, X student X1, okay, I'll just name students, not that you're bad at math, I'm just randomly naming a student. Let's say, I don't know, Cassandra, David, and let's see, who else do I have? And Jeffrey. Okay, well, somebody else might list other students, and so it's not, it's kind of vague. It's not clear as to which student is bad at math. If I ask you, what, well, let me not tell you. You'll see it in the assignment tomorrow. But again, that's just an example. But our sets that we're going to be working with are going to be well defined. Okay, so let's move on to the next page. So we have the empty set. Again, more terminology. The empty set, which is also called the null set. Okay, so let me just choose a different color here. Let's do blue. So when we talk about the empty set, that's the same thing as the null set. And it's basically the set that contains no elements. So the empty set is represented by these brackets, right? Or we can just say, so the empty set is, right, the collection of elements, and I don't write anything in there because it's literally empty. Or I can write a zero or a circle with a slash. Now this zero with a slash does not mean the number 0. It means that I have a set and then there's no elements in there. So what's an example of an empty set? Okay, so if I ask you to, okay, so we're talking about our set S, right? So S is equal to, and I just realized that in the last example, I don't think, or in the last clip, I didn't do set builder notation, so I'll remember to put that in. Okay, so S is equal to, right, all of our students, first student, second student, dot, 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 till the last student. Okay, so if I ask you, the question is, let's do it in, let's do it in pink. How many members, right, or if you want to say elements, how many members or elements in set S, right, in our class, I don't know, own a pet dinosaur. Oops. No, let me get my red. Dinosaur. Okay, so how many of you have actually own a pet dinosaur? I'm not talking about a stuffed animal, but a real dinosaur. I mean, it's a silly example, but really, how many students have this? I don't think anybody does. That's, I'm assuming, right? But I don't think anybody does have, right? They're extinct. So so S. So in this case, how many members? Let's see. In this set, own a peptide. There are no students, right? So if I say, let's see, just to give this names, how many members, elements in a set? So members in set S who own a pet dinosaur. So I'm gonna call that set, I don't know, D, for people who own a pet dinosaur. Well, I can say, you know, let's see, I can erase this. D is this empty set, or I can say D is empty, right? Because there are no students in this class who have a pet dinosaur. And again, you can make up your own example. I mean, I can say how many students in here are siblings. I know there's married students, or one married couple, but I don't think, or from today, from our introductions, I don't think any two people are siblings. So, that can be another empty set. Okay, hope you're having a good time. I'm having a good time. So we have in the next part, recall, okay, the natural numbers. Let's choose a different color here. So maybe a dark green. Okay, so, or light green, whoops. The set of natural numbers. Okay, when I talk about natural numbers, right, there's a lot of different sets of numbers in math. So a specific set are these numbers, right? 1, 2, 3, 4, 5, and so forth. And when I write this big, right, looks like it's an N, right, with the two vertical bars. I'm talking about this set, and we call these the natural numbers because they come naturally to us, right? If we start counting, at 1. If you ask your son or daughter, to count to 10, they're going to start at 1, right? They're not going to say 0, 1, 2, or negative 1, 0, 1, 2. I mean, they could, but assuming they don't know anything about negative numbers yet. Or sometimes they're called the counting numbers, right? Because we learn to count with these numbers. Okay, more terminology. The cardinal number, or sometimes called the cardinality. Let's see, let's do purple. It's my favorite color, purple. So the cardinal number, well, the cardinal number, the cardinality, is represented by this N of A. So number of distinct, okay, different elements in a set A. And again, we read it as N of A. And I want you to note that repeating elements, and there's a typo here, that should be in a set, neither adds a new element in a set nor changes its cardinality. Okay, so what does that mean? So if we move down, so from our example, our set S, our class, S, well, I'm actually going to go ahead and write it in set builder notation since I actually forgot to write that. Okay, so if we first write x1, x2, right, all the way to x sub 20, right, the 20 students in our class, and again, I could write this as a word description. This is the roster method, right, because it's a list and I have commas. The set builder notation is x such that x is a student registered in Math 107, so Cedar Rapids, face-to-face, and this is section 20, right? Because there's a lot of sections. Mine is section 20. So let me translate this because this is important. So this is the set, right, or the collection. Okay, the collection of, and let's see, let me get blue. So the X represents all Kirkwood students. So all Kirkwood students, right, such that, right, this means such that, let me write that in. This bar means such that, right, a condition, there's a restriction here, such that, let me choose, this light blue, such that the Kirkwood student is actually registered in my class. Well, there are only 20 students, right? These are all the light blue. These 20 students are registered in my class. So, okay, that's set builder notation. So set builder notation. It's just another way of writing a set. Okay, so the goal was to find this cardinality of a set. So the cardinality, so n of s is 20, okay, because the number of, and let's see, it's color codes, and that hopefully it's helpful. This 20 is this number of distinct elements in A, right? There are 20 distinct, different students in this class. No two students are alike. I mean, I know there's a quadruplet, I think, Christian, or even if your quadruplet was here or your twin was there, you're still, I mean, genetically you're unique. Not exactly the same. So there's 20. Okay, so I'll stop here just because I'm at 8 minutes, and then I'll continue in the next video clip.